No, the same 200 amp pedestal should not be used for a commercial service as is used for residential. Residential pedestals are designed for single-family homes and typically have lower current ratings. Commercial pedestals are designed for higher current loads and are rated for multiple units. Several factors determine the minimum circuit interrupting rating, abbreviated CIR, for commercial services. These include fault current, circuit protection devices, and coordination. Fault current refers to the maximum possible fault current that can flow in the circuit. This is typically calculated by considering the size and type of equipment connected to the circuit. Circuit protection devices refers to the type of circuit protection devices used, such as circuit breakers and fuses. Coordination is the need to ensure that the circuit protection devices operate in a coordinated manner to prevent damage to equipment or personnel. Higher interrupting ratings are sometimes required in commercial services for several reasons. Firstly, heavy equipment. Commercial buildings often have heavy equipment such as industrial machinery, heating, ventilation, and air conditioning systems, and lighting fixtures that can draw high currents. Secondly, multiple circuits. Commercial services typically have multiple circuits running to different areas of the building, which can increase the potential for fault current. Thirdly, code requirements. Some electrical codes, such as the National Electrical Code, abbreviated NEC, require higher interrupting ratings for certain types of commercial installations, such as those involving large motors or transformers. The interrupting rating of a panel is determined by its internal components, including the circuit breakers or fuses it contains. While some residential panels may have an interrupting rating of 10,000 amps, commercial panels often require higher interrupting ratings, such as 15,000 amps or more, to handle the potentially higher fault currents in commercial settings. The National Electrical Code, Section 110.9, addresses interrupting rating, stating that equipment intended to interrupt current at fault levels shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. Equipment shall be marked with its interrupting rating. This means the overcurrent protective devices you select must be rated to safely interrupt the maximum fault current available at their location in the electrical system. Article 100 provides definitions. Available fault current is the maximum amount of current, in amps, that a circuit is capable of delivering under short-circuit conditions. Interrupting rating is the highest current rated voltage that a device is identified to interrupt under standard test conditions. This is marked on the equipment. Section 110.10 addresses circuit impedance, fault current, interrupting rating, and other characteristics. The overcurrent protective devices, the total impedance, component short circuit current ratings, and other characteristics of the circuit to be protected shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical equipment. This fault shall be assumed to be either between two or more of the circuit conductors or between any circuit conductor and the grounding conductor or enclosing metal raceway. Listed equipment shall be installed in accordance with any instructions included in the listing or labeling. The available short-circuit current at the line terminals of equipment shall be identified and legibly marked in the field on the equipment or made available to those authorized to design, install, inspect, maintain, or operate the equipment. This identification shall include the date the short-circuit current calculation was performed and be available in an approved manner. Determining the available fault current requires calculations based on the utility's available fault current at the service point, transformer impedance, conductor impedance, and other factors. An engineer or qualified electrician typically performs these calculations. The calculated available fault current must be lower than the interrupting rating of the panel board and all overcurrent protective devices. If the available fault current is higher than the interrupting rating, steps must be taken to increase the interrupting rating. This could involve upgrading the panel board, using current limiting devices, or increasing the impedance of the circuit. The NEC requires that the available fault current be field marked on the equipment. This ensures that electricians and inspectors are aware of the available fault current and can verify that the equipment is properly protected. It is important to consider the entire electrical system when determining the interrupting rating requirements. Factors such as the size of the transformer, the length of the conductors, and the type of loads connected to the system can all affect the available fault current. Coordination studies are often performed to ensure that the overcurrent protective devices are properly coordinated and that the system is adequately protected. A coordination study analyzes the time current characteristics of all overcurrent protective devices in the system to ensure that the device closest to the fault will trip first, minimizing the impact of the fault on the rest of the system. Current limiting fuses and breakers can be used to reduce the magnitude of the fault current and allow the use of overcurrent protective devices with lower interrupting ratings. Current limiting devices operate by rapidly inserting a high impedance into the circuit when a fault occurs, limiting the current flow. Series ratings allow the use of overcurrent protective devices with lower interrupting ratings in series with other overcurrent protective devices with higher interrupting ratings. The downstream devices must be tested and listed for series operation with the upstream devices. Surge protective devices, abbreviated SPD, are designed to protect electrical equipment from voltage surges. While SPD do not directly affect the interrupting rating requirements, they can help to reduce the likelihood of faults caused by voltage surges. Ground fault protection is required for certain types of equipment to protect against ground faults. Ground fault protection devices trip when they detect a ground fault current, preventing damage to equipment and reducing the risk of electrical shock. Arc flash studies are performed to determine the potential arc flash hazard in an electrical system. The results of an arc flash study can be used to select appropriate personal protective equipment, abbreviated PPE, and to implement safety procedures to reduce the risk of arc flash injuries. The minimum circuit interrupting rating in commercial services is determined by the maximum possible fault current that can flow in the circuit, the type of circuit protection devices used, and the need to ensure that the circuit protection devices operate in a coordinated manner to prevent damage to equipment or personnel. Higher interrupting ratings are sometimes required in commercial services due to heavy equipment, multiple circuits, and code requirements. The interrupting rating of a panel is determined by its internal components, including the circuit breakers or fuses it contains. Commercial panels often require higher interrupting ratings, such as 15,000 amps or more, to handle the potentially higher fault currents in commercial settings. The National Electrical Code requires that equipment intended to interrupt current at fault levels have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. The available short circuit current at the line terminals of equipment shall be identified and legibly marked in the field on the equipment. Calculating fault current involves complex calculations and should be performed by a qualified professional. The calculation takes into account factors such as transformer size and impedance, conductor size and length, and the utility's available fault current. NEC Table 110.24 provides guidance on calculating and marking available fault current. Coordination studies help ensure that overcurrent protective devices operate in a coordinated manner to minimize the impact of faults on the electrical system. The study analyzes the time current characteristics of all overcurrent protective devices in the system to ensure that the device closest to the fault will trip first. Current limiting devices reduce the magnitude of fault current and allow the use of overcurrent protective devices with lower interrupting ratings. Series ratings permit the use of overcurrent protective devices with lower interrupting ratings in series with other overcurrent protective devices with higher interrupting ratings. Surge protective devices protect electrical equipment from voltage surges and can reduce the likelihood of faults. Ground fault protection protects against ground faults and prevents damage to equipment and reduces the risk of electrical shock. Arc flash studies determine the potential arc flash hazard in an electrical system and are used to select appropriate personal protective equipment and to implement safety procedures. The selection of overcurrent protective devices with appropriate interrupting ratings is crucial for ensuring the safety and reliability of electrical systems. Failure to properly select and coordinate overcurrent protective devices can result in equipment damage, personal injury, and even death. When working on any electrical system, it is essential to follow safe work practices and to wear appropriate personal protective equipment. Always de-energize equipment before working on it and use appropriate lockout-tagout procedures to prevent accidental energization. It is important to understand the differences between residential and commercial electrical systems and to ensure that all electrical work is performed in accordance with the National Electrical Code and other applicable codes and standards. The NEC is updated every 3 years and it is important to stay up to date with the latest requirements. Many resources are available to help electricians and other electrical professionals stay informed about the NEC and other electrical codes and standards. These resources include training courses, publications, and online forums. Staying informed about the latest electrical codes and standards is crucial for ensuring the safety and reliability of electrical systems. Working with a qualified and experienced electrician is essential for ensuring that all electrical work is performed safely and in accordance with applicable codes and standards. A qualified electrician will have the knowledge and skills necessary to select and install appropriate electrical equipment and to ensure that the electrical system is properly protected. Regular inspection and maintenance of electrical systems are essential for preventing electrical hazards and ensuring the safety and reliability of the system. Electrical systems should be inspected regularly by a qualified electrician to identify any potential problems. Any problems that are identified should be repaired promptly to prevent them from escalating into more serious hazards. Following safe work practices and wearing appropriate personal protective equipment are essential for preventing electrical injuries. Always de-energize equipment before working on it and use appropriate lockout-tagout procedures to prevent accidental energization. If you are not qualified to perform electrical work, do not attempt to do so. Electrical work should only be performed by qualified electricians. By following these safety guidelines, you can help to prevent electrical injuries and ensure the safety and reliability of electrical systems. It is crucial to remember that electrical safety is everyone's responsibility. By being aware of the potential hazards and taking appropriate precautions, we can all help to prevent electrical injuries. Remember that the interrupting rating is a crucial safety parameter for electrical equipment. It indicates the maximum fault current that the equipment can safely interrupt without failing. Selecting equipment with an adequate interrupting rating is essential for protecting people and property from electrical hazards. Always consult with a qualified electrical professional for guidance on selecting the appropriate interrupting ratings for your specific application. Ensure all electrical work complies with the latest edition of the National Electrical Code and other applicable codes and standards. Proper planning, design, installation, and maintenance are essential for ensuring the safety and reliability of electrical systems. By paying attention to detail and following best practices, we can create electrical systems that are safe, efficient, and reliable.